Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Kunal, who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation of that. So without any further ado, let me now hand over the platform to him so he can begin his presentation. Alright Kunal, whenever you're ready.
All right, so I just run the code, right?
Yeah, okay, so you can begin there. You can begin by running your code and be sure to be explaining what you'll be doing and also give us a brief rundown of what the project was all about.
Okay. So I'll be running code that will move the robot, and then the robot utilizes its sensors to measure the distance away from walls and other obstacles. So then um, as it goes forward, if it senses that the wall is too close and it can't go forward, then it'll change direction and then continue moving forward when it sees that there's a larger area to move in. So, so right now I'll just be running a simple program where the robot will just move in the area and then it'll move forward. And then once it gets close to the wall, then it'll start turning.
Okay. All right. So can you also?
So as you can see,
Yeah. Go
yeah.
ahead.
So right now the robot's moving forward, and from the terminal you can see that it's measuring different uh, parameters for the distance between different objects in its area. So it was going forward, but now that it's sensing that some of the area is less than one, so it can't move. So now it's turning so
Mm.
that it can move forward.
What do you mean? Some of the areas less than one. Can you clarify?
Yeah, so with the wall right over here, so obviously the robot can't move forward or else it'll run into a wall, right? So it's utilizing its sensors to measure that it can't move forward anymore. So it's turning and like avoiding the obstacle.
Okay. What type of sensor is it using for that? Did you have any idea? I think it should be in the notes.
It's like distance sensors or like proximity sensors.
All right. So at what distance will it stop in front of the wall before colliding? Do you have any idea?
It'll stop at around like 0.3 meters. So if the wall is zero point 0.3 meters or greater away from the robot, then it'll start turning because anywhere under 0.3 meters, then it can't really move.
Okay.
So I think as it comes up to this corner right here, we can see from the meters where it'll start turning to get a rough idea of how close it
Mm,
can get.
okay. Has it been any smoother than this, or it's just your code that's not running properly or something?
Well, it was smoother like while it was going down this longer side, it was much smoother than it is going now because I think it's sensing a few things
Mm, what
because
ab-
like the turning.
yeah, what about in previous runs where you have connected to the robot before? I'm quite sure you did your own testing at some point.
Yeah. It's like moved smoothly and then sometimes it's been like a bit slower.
Did you manage to figure out why that was happening, or?
Not really.
All right. So when it moves, right, I want you to help me understand how your code works here. So when it moves forward, does it move for as long as there is still an opening, or it moves and stops, right? So how did you implement that?
So it'll keep moving forward. Should I go to my code and then talk through that?
We can go there,
Or
but not now. I'm looking for an answer from the top of your head, right? So I want to know, how does it know which distance to go for before it chooses to reset the parameters for your velocity values?
so by using its like distance sensors, it'll just keep moving forward uh, as long as uh, front the front range parameter is greater than zero point 0.3 meters, and then it like measures that out. So then it'll like keep moving forward if it's greater than that.
Okay. And what velocity spike are you using? So what's the linear velocity that will keep moving forward with?
Sorry, could you repeat that?
What is the set value for the velocity when it is realized that it's open? What values do you set for your linear velocity?
Um, I'm not sure. I'll have to go look. Mm,
Okay, so at the moment we can see that it stopped, right? But clearly there are no
yeah, like
obstacles in
right now
front of it.
it's turning.
Okay, so it's still in the turning state. Okay.
Yeah, and then now it's gonna continue moving forward.
Okay. Okay. I want you to do something for me. So when it stops for the next time, I want you to just it, terminate all your programs that are running, then you disconnect a little bit,
Okay.
and then we reconnect again, right? So I want to see, will it be any smoother than this, so that I get to understand how your code is running. So let's give it,
Okay.
yeah, let's give it a couple of seconds to a minute, um, and then we'll start again. Okay. All right. You can stop execution now, and then we want to get it out of that state, so you'd have to use tail before disconnecting. Or you can use the joystick. It's okay anyway. Alright, just move it to the center, then disconnect and connect again. Alright, you can, yeah, we can. The red button there that says disconnect, yeah. Okay, so run your code one more time, and then you can see how it behaves. Okay, it looks like it's much better now.
Yeah.
Alright. Okay, so let's leave it doing its thing, and then open the code editor, and then you can run us through what you did and explain your code. So you don't have to terminate. We want to see if it will go for the long run.
Mm.
So maybe you can make your IDE window slightly smaller so that you can see the robot on the side.
Yes.
Check on Robo Connect. So next to the exit tab. Okay, try the other one on the extreme left. So after the orange cut.
Oh,
Yeah, that one. Yeah.
all right. So this is the code, and what it does, uh, it will uh, it will measure. So it has a bunch of different parameters. So there's like front free, and then there's front range. And so what these measure is the amount of meters space that's available for the robot to move in.
Okay. let's go function by function, right? So let's start with the while loop, for example, because that's where a lot of the moving stuff is, right? So no, below the, we can skip those ones for now. This one, yeah. So let's go line by line for this one. I want to know, what does each variable do, and what form of processing is being done there.
All right, yeah. So here we're running a while loop to measure for like how much gears is available for the robot to move in. We're gonna be scanning the front range, so scanning in front of the robot to see uh, where it can move, and then it'll just say in the terminal how many meters is available, and then this here runs uh, uh, an operating function which measures if the front range is greater than the threshold, which is 0.3 meters, as we previously discussed. And then again, it'll put it into the terminal what it what the front free meters number is, and then this runs an if statement to see if the meters in front of the robot is less than or if it's equal to 0, and then it'll if it is less than 0 and it can't move forward anymore, then it'll start getting data from the left and right side of the robot to see how much meters of space that it can move through there. And then it'll put both of those values into the terminal again. And then here, yeah.
All right. So tell me something. For the front free, right? You are echoing whatever, whether front range is greater than the threshold, right? But then after that, there is a
Yes.
pipe operator, and then BC, then the flag L. Can you explain to me what is the significance of that? Why do you need that there? What happens if you just leave it out and you just put your echo front range greater than threshold? On line 53?
I think I could just do that, yeah.
Line 53. I want to know, why did you have to have that there? If it didn't have, what would happen?
I'm not quite sure.
All right. So if you manage to do this form of implementation and you're not quite sure, you got it from somewhere. So whichever place you got it from, you have to understand what it does. Because at the moment, you're using a tool which you're not quite aware of the purpose of it, right? So I would highly advise you look into this to find out what each and every bit that you're using does. Okay, let's go on.
Right, so then it'll be, then it measures the left range and right range for how much meters it can move in, and
Okay.
then it'll echo those.
All right, so highlight on line 58, right? So highlight line 58. I want you to tell me what's going on with the $sign, the brackets, and then get scan left ray range. What is going on there?
So it's getting the meters value and then assigning it to a variable.
How is it getting it?
It's getting it from the get scan left right range, which is a function that was above.
So it is calling that function, right? That will be the right answer I was looking for. But okay, let's go.
Alright, and then that's the same thing. This get scan right range. So it's calling that function and then assigning it to that variable so that we can use it for the comparison down here in the if statement. So here it's measuring if the left range is greater than the right range,
Mm-hmm.
then it's gonna start turning left. Um, and then it turns by this amount of velocity or like this angle.
All right. So
And then
how are you controlling how much it turns?
we're controlling it through this. So if we change it to like a greater value, then it'll turn more.
Yeah, okay, that's true, right? But if you set a particular angular velocity, for example, there you're setting 0.31, right? It will turn indefinitely. So my question is, how do you control how much it has to turn?
Hmm.
All right, you can look it up. Let's go on to the next stage. So,
Right. And then here, this mint, uh, we're doing some subtraction from the uh, wait, yeah. So the front range minus the threshold. So we're just calculating the distances, and then this is just printing out like the amount of time it'll take for the robot to move. Um, so that's doing that with all these. Uh, the distance to move is how far it needs to go, and the time to move is how much time it'll take. And then we're just echoing all that into the terminal.
all right, all right. Thank you very much, Kunal. So, just hang around for me, and we'll wrap it up here. Okay. Alright everyone, this was Kunal's presentation, and would like to encourage all those of you who would like to try this course to do so, and then you can also come and showcase your work. So until next time, keep